Hello everyone, my name is Lucas Rojas Mendoza and the title for my graduate project is Web Scraping and Machine Learning Based Predictions for FIFA 1994 to 2018 Worldcups. This class was offered in spring of 2018 and this is our teaching staff. And in this project, Beautiful Soup will be used to retrieve historical FIFA soccer information, including historical rankings, statistics, and all the matches and outcomes starting in 1994. This project will involve data cleaning and feature engineering, and 4 different supervised machine learning algorithms will be evaluated to predict the outcome of soccer matches. And the best 2 models will be combined into a voting strategy, which ultimately will allow to make a prediction on the winner of the 2018 World Cup. These are the required libraries and files, and you can download the notebook from my GitHub. Key to this project is the library Beautiful Soup, which is a Python library designed for quick turnaround projects like screen scraping and provides simple methods for navigating, searching, and extracting information and data from the HTML source code of a website, and is well documented. I will be using Beautiful Soup to create 2 data frames. So the first data frame contains all the matches of Worldcups starting in 1994, and the second data frame contains ranking information year by year for all the FIFA teams. This is how the FIFA website looks like, and it's well documented, and it contains data for all the World Cups. So if we wanted to look at the data for Brazil 2014, for instance, we could see the result of each game. Brazil-Croatia was 2-1, and we can obtain this score by checking the class S score test. So I wrote a routine that went through all the data in the website, and ultimately I came out with this data frame that contains all the matches. And something to consider is that we have the scores in just one column, so we'll have to do some data cleaning to split that into different columns. And other data frame was historical data. So for each team, we have year by year the ranking and also the number of matches played, wins, loss, and draws. I have to do some data cleaning for each team for the year 2018 since we have 4 rows, so I condensed the information into just 1 row. And I also created 2 new columns, win percentage and draw percentage. On top of that, additional data cleaning was necessary for the World Cups games data frame. Extract the scores from the column score, simplify the information in the columns date and World Cup, extract penalties score from the column reason win, and also take care of those countries that have disappeared, been created, or that have simply changed their name since 1994, and create a column including the outcome of the game. This is how our data looks like before data cleaning, and this is how it looks like after some data cleaning. So we can see that the scores are in different columns, and we also see the result for each match. We have 160 wins, 116 losses, and 89 draws. The next step was features generation. So for doing this, I used 2 helper functions. One was get rankings that allowed us to get statistics as the ranking of the home team, the ranking of the visitor team the year before of the match, and also other information such as the percentage of wins, draws. And I created the features for each match, as we can see here in this data frame. And here we have all the features ready to start applying machine learning. So I will be using machine learning for outcome prediction, and these are the classifiers that I'm going to be using: K and neighbors, decision trees, random forest, logistic regression, and a voting classifier. So as usual, we start by defining our features, our target, and then we split the data into test and training sets. And to keep in mind, 44% of our labels are wins. And we can use this as a benchmark to our model. So if we predicted all games to be a win, then we would achieve an accuracy of 44% and also a precision of 44%. And the first model was KNN neighbors using 24 neighbors. And this is our confusion matrix and our classification report. So we can see that we are over predicting the number of wins. The recall for the label win is pretty good. It's 88%, but the precision is not that good because of the number of false positives. Decision tree classifier, it was better at predicting the number of losses, but we did not predict any draws. And then we used random forest classifier. We improved the accuracy a bit, but again, we are not predicting any draws and we are over predicting the number of wins. So I decided to use an ensemble method, a voting classifier, to combine K neighbors and random forest using a hard setting. And we can see that we were able to improve the accuracy from 58 and 59% to approximately 62%. And here we can see the confusion metric. So it's better at predicting wins, loss, and we're also predicting some games to be draws. And overall, we got the best accuracy for the voting classifier, and also the overall precision and the overall recall of the F1 score was the best out of all 3 models. So the next step was to use this voting classifier to make predictions on the Russia 2018 World Cup. So there are 32 teams in the World Cup, and they are divided in 8 different groups. And the 4 teams within each group will play against each other. And the 2 teams with the best scores will make it to the round of 16. So to start, for all the matches in the group phase, I generated features using the routines that I generated before. And then I predicted the outcome for each game. Then I created a new column, including the result and also the number of points, 3 points for a win, 0 points for a loss, and 1 point for a draw. And we can see here the code for assigning the points. So Belgium 9 points, Russia 0 points. And then the next step was just to obtain the best 2 teams out of each group. And these teams made it to the round of 16, as we can see here. So for the round of 16, I did the same. I calculated the features, and then I predicted the outcomes of each match. And then after predicting that, we determined the teams that made it to the next phase. So Belgium, Colombia, Belgium is winning. For the quarterfinals, we have 4 matches, and I used my model again to predict the result. And then for the semifinals, the same thing. So Brazil will win against Spain, and Portugal will win against Germany. So the final will be Brazil versus Portugal, which my model predicts that Brazil will win, and the 3rd place will be Germany, which will win against Spain. Some conclusions. So I was able to scrape data for 211 countries using web scraping. Pandas was extremely helpful, and we achieved an accuracy of 62% using a voting classifier. And future work should include player-based features in order to increase the performance of our model. And here are the references. And thank you very much.